Hello, welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing of comparing two variants. So if we want to compare or say test the equality of two variants from two populations, so we will establish the null hypothesis H0 that sigma 1 square equal sigma 2 square. And the alternative hypothesis is if it is the one-side test, it will be either sigma 1 square less than sigma 2 square or sigma 1 square larger than sigma 2 square. So if it is a two-sided test, so the alternative hypothesis or H1 is sigma 1 square not equal to sigma 2 square. So it's very natural that we take random sample from these two independent population with size n1 and n2. Then the F statistic, which equals S1 square divided by S2 square. Here S1 square and S2 square are the sample variance. So we take sample and get the variance from these two samples and take the ratio, then get this test statistic. This item follows so-called F distribution with n-1 and n1-1 and n2-1 degrees of freedom. So F distribution has 2 degrees of freedom. So if we put S1 square on numerator and S2 square in the denominator, then it will be n1-1 degrees first, and the second degree is n2-1, right? So this is F distribution's density curve. So for say if we have one-sided alternative test, either sigma 1 square less than sigma 2 square or sigma 1 square larger than sigma 2 square, we only think about the one side. So if we want to test the sigma 1 square less than 2 sigma square, this is the alternative hypothesis. Then we will look at this area if this is a sample statistic less their critical value. Here is 1 minus alpha. So here will be 1 minus alpha. So if the sample F on left side in the white area of this critical value, then test will be significant. And similarly, if we want to test one side, sigma 1 square larger than sigma 2 square, then we look at if the test statistic F on the right side of this critical value. So this critical value is F alpha V1 V2, right? But for the two-sided alternative, sigma 1 square not equal to sigma 2 square, we will look at both. If the test statistic located in this area or this area, then any one of these happens, then we will say the test is significant, right? So next we look at an example. An experiment was performed to compare the abrasive wear of two different laminated materials. And 12 pieces of material 1 were tested by exposing each piece to a machine measuring wear. Then 10 pieces of material 2 were similarly tested. So sample 1 size is 12 and sample 2 size is 10. In each case, the depth of wear was observed. And the samples of material 1 give an average wear of 85 units and with a sample standard deviation 4. While the samples of material 2 give an average of 81 with a sample standard deviation of 5. So we assume the population to be approximately normal, and we assume that the two unknown population values were equal. So the question is, were we justified in making this assumption. Use a 10% level of significance. So the solution is, let sigma 1 square and sigma 2 square be the population variance for the abrasive wear of material 1 and material 2. Then we form the null hypothesis is sigma 1 square equal sigma 2 square. And alternative hypothesis H1 here is sigma 1 square not equal to sigma square. So this is two-sided test. And alpha is 0.1. Then critical region, from F distribution table we can see F 0.05. Why? Because alpha is 0.1. So here is half alpha. So F half alpha 11.9, these 2 degrees of freedom, because we will form the F statistic is S1 square divided by S2 square. So this N1 minus 1 first, N2 minus 1 second. So we find that this critical value 3.11. And we can also find F 0.95. So 1 minus half alpha with these 2 degrees of freedom. And F distribution has a fun feature that this one will be F 0.05 and exchange the degrees of freedom. So we finally get 0.34 for this critical value. So therefore the null hypothesis is rejected when F is either less than 0.34 or larger than 3.11. So this is a two-sided test. And F is the division of sample variance and with these 2 degrees of freedom. So the computation of S1 is 16 and S2 is 25. Then we get this ratio is 0.64. So you can see 0.64 in the white area, not in the blue area, right? This is F half alpha, and this is F1 minus half alpha, right? This critical value. So because the 0.64 not in the critical region is the blue one. So we get a conclusion that we do not reject H0 and conclude that there is insufficient evidence that the variance differ. Thanks for watching.